So basically, the main thing today is going to go through a lot of examples to make sure that you understand how to do your differentiation of trig. All right? Things like chain rule, things like quotient rule, things like product rule, and all that has to, you have to take all that into account when you actually differentiate trig. All right? So you need to be able to think about it as a chain rule or product rule or quotient rule. And then we'll do some problem solving. And I want to finish this lesson, if I can, with all the 10 examples. All right? Now, so this is a summary. If we have sine x, the first derivative of sine x is cos x. And then cos x, the first derivative is minus sine x. And tan x is 1 over cos x. Cos square x, all right? Now, you don't have to know the sec square x, but you do need to know the 1 over cos square x, all right? Although in your formula sheet, those are the only two given, all right? My gut feeling, this is not really tested, but yeah, those two will be the main thing. Now,
wait, so didn't you write the test?
Sorry?
Didn't you write the test?
Yeah, I did.
And how's it
But
your gut feeling?
I'm not talking about the test, I'm talking in general, the weights exam, all right? So my gut feeling in the weights exam is they did not specifically give you the 10x, so they might expect you to come up, they might expect you to, for the exam, they might expect you to derive 10x based on the quotient rule.
Yep.
All right? So don't think specifically they will actually test
I
it.
stuffed this guy, so
Now,
it's too small.
remember, everything will be in
already
radians. Must be in radians, cannot be anything else. All right, cannot be in degrees. So when you're doing all this, set your calculator up, class back up as radians. Now, very quickly, you remember things like the transformation of trigonometric function. So B is the change in period, C is the change in phase, A is the change in amplitude, and D is the change in equilibrium. All right. I normally like to factorize the B out. All right. In terms of derivative, it's not as important factorizing the B out. You can get away without factorizing the B out. But if you are doing a transformation, you must factorize the B out. All right. So if you've got something like this, y equals to a sine b x minus c plus d. Think about the chain rule. What happened is you must actually factorize, you must actually differentiate this as well. All right, that becomes a sine u. So dy du equals to b, dy du equals to b, and du dx equals to b as well. So therefore, you've got dy dx equals dy du times du dx. So what you need to think about is, you can ignore the d. All right, shifting up and down, it really doesn't change the gradient at the point x. But you must differentiate this by itself and differentiate the inside. Differentiate the outside and then differentiate the inside. Yeah? So if you differentiate the outside here, which is a sine b, differentiate that becomes a cos b, all right, or a cos u, if that's u. Yeah. And then you differentiate what is in there, which is bx minus bc, so it's actually just b. So it's ab cos bx minus bc.
I don't know if I'm right.
So remember, you need to differentiate that first, and then differentiate the inside. All right, everyone happy with that?
Otherwise, you go.
Let's keep going.
Sine 3x.
All right, so therefore, this is just a summary. Basically, it is the same.
Yeah.
What you need to do is, once you've got something plus d, differentiating, you really don't have to differentiate the constant at all. You just need to differentiate the outside and the inside. All right, the outside and the inside, the outside and the inside. That's it. A is just a factor. So this is in a Way's formula sheet. That's why I say in Way they may not test you for 10, but they will expect you to, in the syllabus point, expect you to derive a differentiation of 10 from the quotient rule. Now, let's try this, the example, y equals to sine 4x. So what you do is differentiate sine x, which is cos x, correct? Which is cos 4x. And then differentiate the 4x there, which is 4. So it will become 4 cos 4x. Yeah? So try this. Here, you can ignore the plus 1. But differentiate the cos x,
Yeah.
it will become minus sine x, correct? Then differentiate this, which is pi. Alright, try the rest, please. I'll review my answer in a few minutes.
Yeah, mate, I'm good.
So remember, what you need to do is here differentiate the 10 and then differentiate the 3x. You've got two terms, differentiate the sine x and then 3x in there, differentiate that and whatever is in there, outside and inside, outside, inside. Alright, here, this is the slightly trickier one. You can combine cos and sine trig function with e as well.
It gets hard.
Sorry?
It gets hard.
It's not really that bad, come on.
Wrong kid.
I think the hardest is when you combine a few things together. Some of them will be tricky.
Yeah. Did you
Alright.
say they were easy though?
Well, I'm more experienced than you, that's all.
Yeah, okay.
Alright,
Fair enough.
experience counts.
Ooh.
And you can see that I make a lot of mistakes, right?
Yeah.
I don't have enough practice. I have more experience, but I don't have enough practice. So see, I've differentiated the cos, and it became minus sine x over 2. And then differentiate what's in there half. Alright, use the chain rule. Chain rule apply here. Alright, check your answer please. So f will become 6 cos pi over 3 minus 3x. This one, sine x will become cos x, right? So it's minus 2 cos of that. And then you differentiate minus 3x, which is minus 3. Minus 2 times minus 3 will give you 6 cos. Alright, are you all happy with that?
Yeah,
Good.
good.
Let's move on. Alright, now, example 2. You need to determine the equation of the tangent to the curve y equals to cos x as the point where x equals pi over 4. Answer in the form ax plus by equals to b. Alright, now, think about cos x when x equals pi over 4. Can you remember
With 2 and
how to find the exact value?
So it's root
Yes? Triangle? Yes. Remember your triangle. So it's pi over 4, 1, 1, and square root of 2. So you could work out your cos of pi over 4.
root
I
2
don't
and 2.
really want people to remember the numbers. But using the triangle is a lot easier. It's a lot more intuitive. If you've got pi over 3 or pi over 6, so if you've got pi over 3, you know this is the same. Pi over 3 and 60 degrees. If you draw a right angle triangle, that will be the same. That will be, let's say this is 2, this is 1, this is square root of 3. And this is pi over 6. Makes life a little bit easier if you know the triangle, rather than memorizing the number. So what do you need to do first? Find straight away dy dx. Right? Find the first derivative and substitute x equals pi over 4 in there. And you should have minus 1 over square root of 2. And then keep going. You need to find y when x equals pi over 4.
Return to.
Then you know the gradient, you know y, you can work this out. Now, here the way I simplify it, I will multiply every term by square root of 2 straight away. Alright, so that I know in that form, I now have square root of 2y minus 1 equals to minus x plus pi over 4. Right? So I multiply square root of 2, so that became 1, that became square root of 2. And take away, multiply square root of 2, minus 1, bring it into the bracket, minus x plus pi over 4. So therefore, now you would have, that is x, that's not 1, alright? Sorry, that has to be x. Square root of y plus x equals to 1 plus x over 4. I'll sort it out. That's x. Alright, when I put it out, I will sort it out. So that is in the form of ax plus by. And then the d is 1 plus pi over 4. Without calculator, you are not expected to work this out. Alright? Remember in the exam, in calculator 3, if it is pi, it is e, just leave it as pi or e. Do not simplify it. Everybody cool with that? Yeah? I'll move on now. Next. Example 3. Oh, let's do example 3 first, please, before I show you the answer. Do example 3, please. Example 3, consider the curve defined by the rule y equals to 2x minus 2 sine 2x. Determine the coordinates of any stationary points over the domain minus pi. X is between minus pi and pi. Alright? Now, think about it. Stationary point, what does that mean? What is 0? Gradient is 0 and dy dx equals to 0, correct? Now, you've got to use your skills from year 11. How do you solve it? You got to remember that. You got to remember that.
Yep.
Do I have to double it? I have to double the domain? Yes, domain confinement, you know what I mean? So I have to double it. Negative 2 pi and 2 pi.
Last week, bro. Last week.
So adjust the domain because it's 2x.
You need to know the domain. You need to remember what if you're in my class, you should remember what I taught you last year. If you can't remember, let me go through it with you. Now, first, important thing is you must know how to get your dy dx, which is differentiate 2x, you have 2. Differentiate sine 2x is minus cos 2x times 2 cos 2x. Therefore, it became minus 4 cos 2x. Alright, remember, you are given the domain of x between minus pi and pi. When you solve for that, you know it is cos 2x. You must change your domain to minus 2 pi and 2 pi. Recall that?
I got that.
You must remember that. If you don't remember that, you are not solving it correctly. Make sure that you change the domain. You've got x to 2x. So multiply minus pi by 2 and multiply pi by 2. Then, I normally draw my unit circle. So I know I'm looking at cos 2x is positive. I'm looking at first quadrant and fourth quadrant. From there, I can solve for cos 2x. Once you know what 2x is, you should be able to solve for x. Yep.
Isn't the derivative of sine x negative cos x? No. Oh, no.
No, it's cos. It's cos is negative sine. It's okay.
Okay.
It's a matter of practice.
Yeah.
It's a matter of just
Because you rush kind of
accuracy. Yeah.
I'm not even rushing.
Alright? So this is how you solve it. Always remember. Now we are getting to the point that you must remember how to work on your domain. Alright? How you change from x to 2x, the domain. That is so important. If not, you will not be able to solve it properly.
So don't you need coordinates
Yep.
as well?
Hmm?
Don't you need coordinates as well for that? So you have to solve.
Oh yes, it should have coordinates. I haven't worked out the coordinates at all. Sorry, my fault. Yes, you should work out y as well. I was just working out x.
It's very difficult, sir.
It's my fault for not working out y. So I will put in the coordinates a little bit later. Yes, I missed that bit. I missed the coordinate bit. You must work out the y. So there will be 4 coordinates. Alright?
Oh, I can't be bothered.
Yeah, in the exam you'll get 1 mark less, I think.
Oh, I'm probably gonna.
No, I'm not even doing this. That's
So-
a waste of time.
Important
mark,
thing
that's a waste
is
of time.
you've got to be able to link it back to year 11.
Why is that a half? That is completely a waste
Alright,
of time.
I'll move on to example 4, if that's alright.
Yeah, go for it, sir.
Okay, let's go. Now, example 4. Find the coordinates of any points on y equals half tan to x for the domain 0, x is between 0 and 2 pi, where the gradient of the curve is 1. Now, dy dx this time is 1. It's no longer 0. Why is it
Negative.
no longer 0?
So you start here. You go negative.
Its gradient is 1. Yep.
5 times 3. This is fine.
Yeah.
So this time you got to work out your dy dx, and then again tan to x, you need to change
Yup.
your domain,
Yup,
correct?
yup.
You must remember you need to change your domain in this case. So you are given the gradient.
Dumb. So dumb.
Do you need a calculator?
Help me now.
1 is 2.
Question like this,
2x.
really important. Look at the domain.
How you doing that shit, bro?
Bro, just do it, mate. I thought you were good at methods last year.
Yeah, no.
No, mate. Come on.
Yep, yep, that's correct.
Is it 1 over? How did you just...
dy dx equals that.
Oh, because you just...
Okay, I find dy dx is 1 over cos squared 2x because differentiating tan to x
So isn't it?
is 1 over 2. 2 over cos squared 2x. Therefore, it becomes the whole first derivative will become 1 over cos squared 2x. And you know that that's equal to 1.
I got it.
Now, remember, I'm going to stress this again. If you've got y equals y squared equals to 4, y is equals to plus or minus 4, alright? Where square root of 4 is equals to 2. Please remember this.
So I think you mean plus minus 2.
Plus or minus 2, thank you. Square root of 4. So make sure that you know if that's y squared equals to 4, y is plus or minus 2. Which means
get
here
0,
you
pi,
need
2
to
pi,
have
3 pi,
plus
4
or minus. And of course, again, you need to change the domain.
That's
Changing the
that's 2x.
domain, multiply both sides by
Oh, yeah. But like, for your 2x, you got that, right?
0, negative 2 pi, 2 pi.
Pi, negative pi.
So I know
2 pi.
here,
Isn't it 3 pi and 4 pi? You can't go in the negatives.
yeah? So you know it's there.
Domain.
So it's from 0 to 4 pi. 0, pi, 2 pi, 3 pi, and 4 pi.
Question!
Alright?
I was reading the last question.
Yeah, fair enough.
It's pi.
So you see,
That's right.
really answering a question like this makes life easier if you've got a unit circle. You've got your
pies,
quadrant
0,
and you've got your domain.
But then you
This
have
is
to
what I
divide
like
it
to do.
by two.
I like to have the domain and that, so that I know where the
It's
points
plus,
are.
it's plus and minus 1.
Alright,
so I'm
again,
not finding the
I
coordinates.
haven't worked out the coordinates yet, but you should be able to work out what the coordinate is.
So that's too much time.
So that'd be like 7 marks.
No. In year 12, we're looking at that will be possibly solving it. Solving that will be 2 marks.
Yeah.
That will probably be 1 mark. So, and then
The coordinates, yeah, but the
that
coordinates
will
take
be
too long.
1 mark. Oh, that we might not even give that mark.
Yeah,
Straight
you-
away go to here, and then the coordinates another mark. That's all.
How?
So I made a mistake with the
I'm gonna
with
skip
this
that.
question
That's
where
Yeah,
I
you put
did not
0,
find the
like
coordinates.
10,
I
0.
should have.
It's 0.
There's 0. Okay. Well, 0 is like the only easy one.
No.
10 pi is
10 pi is-
undefined.
10 pi is 0.
10 pi 0. So what's...
I mean, sorry, 10.
No, 10 pi.
No, because it's something. It's 2 times it, right? So 2 times pi is 2 pi, which is 0. Same
Yeah,
thing.
so that's why.
And then pi on 2 times 2 equals pi, which is 0. It's actually not that bad if you deepen.
Yeah. But they're actually like all 0 though. Aren't they just like literally all 0?
Yeah, literally
They're all
0.
0, yeah.
Wait.
They're all 0.
D dx. Log D dx. 2 cos. 2 cos x. D dx. 2 cos x.
Without the y, you can't find it. I don't remember this one. You don't gradient, you don't remember this equation.
What did you do for 5?
Alright, my fault for not finding the coordinates. Like I say, I'll sort it out a little bit later. I got to go on to, oh, this is running short of time. 5. Now, point of intersection,
Did you get root
I mean-
for the intersection?
if you plot it on your class pad straight away, you know that it is not perpendicular to each other.
Oh, yeah.
But you need to use calculus to show that they are not. How
So
do you
just
do
find
that?
it. So,
Do you need to find every single point? There's no domain
no, because it's
described there.
pi. If it's pi on 2, then that's
There's only 2 points that you need to look at.
0.
Because everything is plus 360 degrees plus 2 pi plus
that's
2
1,
pi.
not 0.
Right?
Yeah.
So if
1
you
minus
can-
0 equals 1.
If you can
One
show
is
me
equal to
2
zero.
points are not,
1 minus
and
0
then the rest
equals
will be
1, not 0.
just follow
Yeah, so
because
then
of
what?
the way the curve goes.
Right.
Right?
Right, this has to
So there are 2
both of
points that
this
you
has to
need to
equal
tell
0,
me
right?
that they are the intersection are not
One
perpendicular to
minus
each other.
Equals.
All right?
1, not 0.
I will
Yes,
I will
that's
show
right.
you in a minute.
Yeah,
Let me
that's what I just said.
get
Oh, I
the
thought you said it's right.
draw it for you on
It's pi on 4, it's
yeah.
pi on 4.
Plus, you can just.
So that makes it root 2 and 2, take root 2 and 2.
Yeah, but you just.
Like, yeah, I knew that.
Put the cos x over to one side, divide it by cos x, you get tan x equals 1. It's much easier, right?
Or you can just like use your understanding, I guess.
I mean-
I found it kind of easy this week.
Yeah.
But yeah, it does make sense.
Who's got a toilet?
All right. Now let's have a look at this one very quickly. This graph. So you can see from the graph, 2 sine x and 2 cos x. Look at where the intersection is. You need to say that this point and this point. All right. You really need to look at just the positive and the negative area because that is plus 360 degrees or plus 2 pi. That is another one plus 2 pi. All right. the rotation. So you need to tell me that point at that point or this point at this point. That's all. They are not, drawing it, you know that it's not perpendicular. But you need to prove to me. How do you do this? Find the instantaneous gradient at this point for sine x and for cos x. Find the instantaneous gradient at this point for sine x and cos x, and then show that multiplication of n1 times n2 is not minus 1. That's important. That's all. You must recall m1 times n2, gradient of 1 times gradient of 2 is if it is minus 1, that is perpendicular. No, it is not. I am showing you the you got to work it out. Alright? You got to work it out. Of course you don't know what the point of intersection is. You need to work it out. You really have to work, you really have to know your trick.
Perpendicular.
So you work out 2 points because you're working out within the 360 degree, that's all.
Well, so
The whole thing goes in circle. So if you know the 360 degrees, you know that there's only pi over 4 and 5 pi over 4.
Oh, quotient rule. I mean, product rule.
So this is just basically asking you to look at tangent of x equals to 1.
No? Is that not?
So you
I mean,
need to solve it.
chain rule, honestly.
Alright?
Oh,
Things like this you need to
that's
solve
what I
for
meant to
the
say.
intersection.
I don't know the
Because
name.
you've got
Thing.
two functions. So you equate two functions. So 2 sine x equals 2 cos x. 2 sine x is equal to 2 cos x. Divide both sides by 2. So you got sine x over cos x. And then divide both sides by cos x. You got tan x equals to 1. So therefore x equals to pi over 4 and 5 pi over 4.
I forgot product rule, bro.
Here, I did not draw the unit circle, but you can if you want to. Alright, so now you know x pi over 4 and 5 pi over 4. Find the gradient of 2 sine x and the gradient of 2 cos x is at these 2 points. Alright, so for example, when y equals to 2 sine x, you know that dy dx is the cos x. So work out cos pi over 4 and cos 5 pi over 4. One is 1 over square root of 2, the other one is minus 1 over square root of 2. Then, when y equals to 2 sine x, 2 cos x, work out dy dx, and then you know what the gradient is, right? So at pi over 4, the gradient is 1 over square root of 2 times 1 minus 1 over square root of 2. That's minus half, which is not equals to minus 1. Therefore, they are not perpendicular. Alright, same with at pi 5 pi over 4.
So isn't
Sorry?
it 2 cos x? So 2 sine x.
2 sine x, 2 cos x, my fault. Yes. Yes, my fault. Yeah, 2 cos x, 2 sine x, that's fine. That's all, yeah, my fault, totally my fault. I'm just looking at cos and sine.
Because you can factorize it out, so it doesn't matter.
What?
So
What are you talking
my
about?
fault.
Factorize.
Dude, what are you doing?
So that is...
Wait, where are you? Where are you? Where, what are you talking about? Bottom left.
Where
that's
y
the
equals 2 sine x.
Oh, yeah.
2.
Be quiet.
2 over
Do be quiet.
same 2 and 2.
It's so rude.
Yeah, totally my fault. So that is 4 over 2, that's minus 2. 4 over 2, that's minus 2. Alright, so since they are not alright, so my fault is I forgot the 2. I just
Is that right?
differentiated the cos x and the sin x.
Can I just
So you
check
can
something?
see that
For the second one here.
They are not equals to 1, therefore
the answer.
the tangents are not perpendicular.
I got 18.
Bro, how you get 18?
18 cos squared.
Because this has to be a 3 here, so that means 18. Yes. No. What? 18.
6 and 7 should be fairly straightforward,
So
but
it's
8, 9,
first
10.
it's 3 then.
If I cannot
Yeah.
finish, I will push 9 and 10 to tomorrow. All right. Tomorrow I only have about 3 questions or 4 questions to show you. That's all.
It's a negative 18 or
Fine.
18?
18. Because
Alright.
cos x differentiation is negative
Are
sign.
you happy
Oh,
for
you
me to
made it
move
so
on?
switches. Yeah. Right.
Yeah.
But then the rest is right.
So think about this.
Thank
You need to find the intersection point. So if you are asked to find, if you're not given the intersection point, you need to find the intersection point solution. That's one step. The other step is find dy dx of both. Alright, dy dx of both, and then dy dx at that point. Alright, this time is pi over 4, you solve the intersection. And then you can work out what the two tangent is. Alright, very quickly, if you've got power of trigonometry function, it's the same thing as well. What you need to do is, this is a trig function. That is to the power of something, right? So make sure that you differentiate that, which becomes power function and that function n minus 1, and then differentiate the inside. Alright? Remember, differentiate the outside first. So this would be whatever, it becomes the power rule. N times that to the n minus 1. And then differentiate the inside. Yeah? So differentiate the outside and then differentiate the inside. So it could be sine, it could be cos, and it could be tan. Taking it one step further. So example, now for the first one, if I've got 2 sine square x, that is actually y equals to 2 sine x all squared. Alright? So now I differentiate the outside first. The dy dx will therefore be the 2, I'll keep that. I'm not going to worry about it. So this will be 2 times sine x to the power of 1 because it's 2 minus 1. Alright? And then I differentiate in there, which is cos x. So therefore I've got 4 sine x cos x. Yeah? So think about it. That is something like, imagine that that is y equals to x squared. 2x squared or
What did you get for D?
x plus
It's
1
got 2
squared.
tan x. cos
So
squared.
therefore there's 2
2 tan x.
times 2 x plus 1.
Wait, no.
And then differentiate what's inside there. Alright? It's the
I
same
know, sorry, it's just
principle,
1.
except we are
Just tan
using
x plus-
trig function, that's all.
What'd you get?
So I differentiated that, differentiated sine x, sine square x, so it's 2 sine x, and then differentiate sine x, which is cos x.
Brother, what?
Now, part B is the same as well.
No.
Let's not worry about the minus 3 first. Let's think about this. Because minus 3 is a coefficient, you multiply that in. So you will
That's bad.
first
I try to simplify, but it's funny. Correct.
think about this as cos 2 pi plus 2x
So
plus
1
pi
plus-
all cubed. So therefore, differentiating that will become 2 cos squared 2x plus pi, and then differentiate
Yeah, I don't think you need to simplify, I think.
the function itself, which is cos, which is minus sine 2 pi plus pi, and then differentiate what is inside. So you're going to think about differentiate from the power, and then to the cos, and whatever is inside. Alright? That's a general rule. Think about what you're going to do outside, inside, and then inside. That's how I see it. Alright? So you think about that, you've got minus 3 is always there. It's just a coefficient. So I started by differentiating this first. Cos 2x plus pi to the power of 3. Alright, power rule. So it's 3 times cos 2x plus pi squared, which I wrote it this way, right? And then ignore that, ignore the 3. So I differentiate cos 2x plus pi, which is minus 2x plus pi. And then I differentiate what's inside this bracket, which is 2. Yeah? So think about it as chunk. You're chunking it down. Big chunk, the whole thing first, with the power rule, and then forget about the power, and then you look at the bracket. Yeah? Everyone all right with that? I'll repeat again. The 3's coefficient, it will multiply in.
You're
all right?
right.
So the first bit here is that.
For the first.
Just the whole thing. Let me circle it. So this becomes this bit here.
This one here.
I start off with that. And using the power rule,
he has negative
I've
sine
got that.
2x. Like, shouldn't it be negative
Agree?
sine q?
yeah? And then the next bit,
Differentiating
I don't look at the 3.
because
I
The
just
3 just like
do this,
disappears, 3
differentiate
should be
this,
there. Yeah.
and that becomes that minus sine.
You just got to think about it on
2
the
pi.
outside, yeah.
Yeah.
You gotta
And
think about
finally,
that,
the last bit, I just look at this 2 pi plus 2x plus pi, and that differentiate that, give me that 3 distinct area, sort of area. Yeah? Are you all okay with that? All right, let's try C, please. You need to rewrite C. I mean, if you want, you can multiply the coefficient together. That's fine. But you don't have to if you don't want. If you are not asked to do that. Try this, please. That would be sine x to the power of half. All right? That will be sine x to the power of half.
What do you get for sine?
negative 4x sine x squared minus pi.
Negative 4x
Sine
sine
x squared minus pi.
x squared minus
I'm writing it out this way. It makes life just a little bit simpler because you can see that it's going to be a power rule.
Wait, minus pi on 2, you mean?
Yeah.
Yeah.
So if this power rule
Okay.
is half
Makes it
sine x to the power of minus half, correct? And then you differentiate the sine x again, which is cos x, right? So here, I forgot the cos x, my fault. Differentiate the sine x will give me cos x, which means I need to redo this. Give me 1 minute. So that should be a cos x. That should be a cos x. Cos x. So therefore it should be cos x. Alright? And of course, the last one. Of course, the last one, you need to be able to do the power rule for the 10 square first, and then take away the 10 square, just like 10x plus pi over 3, then the inside. All right?
So what you got from
The
there?
power first, and then the trig, and then the and then whatever's inside. Yeah.
What's the root 210?
Isn't that what golden eggs?
I mean, I'll tank that as well. I can't be bothered.
All right, I'm going to review my answer for that one.
Because you didn't times it by.
Yeah,
You-
because
this
this
is-
is like.
See, so I've done half.
I think it's supposed to be root 2x instead of 2 root x.
Half is still there.
Because this
Factorize,
right is root 2x.
differentiating this, not factorizing this, 2, 10x plus pi over 3. power of 1.
It's like
So that's
it's
that.
2x to the power of
And then
negative.
I differentiate that.
Negative half,
It becomes
isn't it?
cos square x plus pi over 3.
You see this?
And therefore,
So if you differentiate
No, it's
you-
root 2 x power.
summarize it, or
2x
simplify it,
the
you've
original
got
half.
10x over
The
cos
original
square
thing
x.
is root 2 x half, right?
Now,
Yeah.
if you use class back, it will give you a slightly different answer. It really
That's
doesn't
just
matter.
root 2 times.
This is the way that you should be doing it. I think not a class
Yeah,
back.
but isn't it all? It's all.
It's all root, yeah.
After this point, that's all.
Yeah, so
After
root
this
2
point, that's it.
times root x.
Because half times
Yeah,
Isn't it
root
half,
x.
what? Yeah.
half times 2x?
1 cos square x
Sorry,
plus
negative half.
pi over 3. Because that's
Is it not that?
that is differentiating 10
Yeah.
x
Wait,
plus
no,
pi
no,
over
no,
3.
it's x.
Alright,
Wait, no.
okay, the next
No,
one
it's
is a composite function.
Oh, wait.
So it's 1 over.
If you've got sine of
root-
Wait,
x,
that's
Two
true.
x.
That's true. Wait.
you
what am I
need to
doing?
be able to differentiate
Yeah,
the
so 1
inside
over 2 root 2
and then
x
the
is
cos
1x.
fx.
Yeah, I think I'm
Alright,
right.
same with cos as well, minus f dash x and then sine fx. So what you do in this case is, you differentiate what's inside, and then you differentiate what's outside. Alright? Inside, and then the whole thing. Do the inside and do the whole thing.
You
Alright?
1, 2,
Root
Same
2
with this.
times
Do the inside and then the whole thing.
x.
Oh, preseason testing. Let's go.
Don't worry about madly copying this down because you will get this in the PowerPoint anyway, once I uploaded the slide. Alright?
Enough time, is it?
So,
15.
I'll show you the first one. dy dx of 2 cos x squared. dy dx of 2 cos x squared minus pi over 2. So, why do you have a minus 2? There shouldn't be a minus, there should be a positive there. I should be looking at this first. So that is 2x, correct? 2 is still here. dy dx equals to 2. Alright? So I differentiate the x squared. And then I differentiate the cos x squared minus pi over 2 times minus sine. I know where the minus comes from now. Minus sine x squared minus pi over 2. Alright? So that minus should have been associated with the sign rather than minus 2x. Alright? This is how you do it. So look at the inside first and then the whole trig function. Alright? Inside first, which is this 2x, and then the negative is associated with the sign. So far so good, everyone? Yeah. Sure? Alright, try the next two. I might leave, I might still do one example of triangles.
So, are we doing question 8 or?
Yeah, I'm going to do question 8.
Okay. Was I right or was I wrong?
Negative sign. I associated the negative.
I was wrong?
We were both wrong though.
I put a negative. I was
That is
too
just
fast.
half times 1.
Just realize that the negative here,
So I have to just change this to.
the negative here should be associated with the sign. I was doing it in my mind, and I wasn't thinking when I was writing
Yeah,
it down.
true.
All right. So
What do you
here,
get for D?
you know there's a square root of 2x.
1 over cos.
You should
square
know
half
dy
x.
dx of square root of 2x.
Yeah, negative.
Negative, yeah. Sorry.
d dx of
Bro,
square
I
root
always
of
miss a
2x
marking with the negative.
is d dx of 2x.
My dumb mistakes
to the
are
power
like
of
1 plus 1 equals 3.
half.
See?
Yes.
Right.
something
So
like
therefore,
Not
you
like-
know this
not like
is
negative.
half
that. Mine are always negative.
times 2, that is half. 2x to the power of minus half, which is 1 over 2 square root of x. And then do the sine x, d dx sine x.
I think I've not seen 6 pages in my back.
What do you mean?
Right. Yep.
Does it matter if you put a negative in the fx derivative?
Which one?
Can you put a negative in front of the sign?
Yeah, it should be. I was thinking too fast. I wrote that down first. Yeah. It was my fault when I did that. It should be in front of the sign. But when I wrote it down, I was just like, I wasn't thinking. All right. So here, I did the power rule first. The power rule gives me the half sine x square root of 2x. All right. Then I do without the power cos square root of 2x, and then I did the inside. So again, just make sure that you are splitting it into smaller chunks. Once you know that, it's a matter of practice.
Wait, so where'd you get the half sign?
Sorry? So,
For eight,
this
you
one
get,
is from the
negative
power
2 pi.
rule. Alright?
Yeah.
This is from the power rule. Should
Yeah.
be 2 sine. I don't know what the other half.
I thought it was
I
gonna be
wrote.
like fucking.
It should be 2 sine. I don't know what
Rest of
the
the
other
x squared, I was
half.
gonna be like, oh, I'm
There should
sure
be
I have to
2.
know x squared, pi squared. But it just goes to
No,
zero.
we're retarded.
Because it's
Really?
2 sine
Yeah,
square
we
root
didn't
of
use
x.
product rule. We didn't use
It's not product rule though, they're not timesing together.
Yeah, that's 2.
Yes, there are. There's an x here and an x term here. 2 different x terms.
Right, you just ruined my. Now let's do everything again.
That's so long, bro. I don't want to do
Just
that.
it's gonna be the same answer as well, I can guarantee it.
Alright.
I can guarantee you it's the same answer.
Isn't it, why is it
Sorry?
don't you, when you differentiate the inside of the
Yep.
square root of x, shouldn't it just be x and 2x?
No. It's, you are differentiating. Differentiating 2x all to the power of half. So therefore, that becomes 2x.
Fam. It's gonna be the same answer.
Sorry?
2 times 0 plus 2 by negative 1 plus 2 by negative 1.
Even with E, there's no mystery about that. You must be able to do
Close enough.
the cos x, which is minus sine x.
Negative
So
4
therefore
pi.
it's 3 sine 3x. And then you differentiate e to the power of 3x, which is e to the power of 3x. Then the 3x there, which is 3. So it's 9ex to the power of sine e to the power of 3x.
I can't be bothered doing more stuff. Quotient rule. I'm not doing that. No chance you catch me doing quotient rule, brother.
All right. Now, the question is, should I leave the last 3 questions to tomorrow?
Yes.
Okay, that's fine. I don't mind. Because tomorrow there are 4 examples, worded examples. And then 3, yep, I should be able to get through it tomorrow. Just please make sure that you're on time, alright? I'm not going to do 8, 9, and 10 until tomorrow. So I will upload the video first and the solution to 1 to example 7. Alright?
Do we have homework, sir?